All right, so today we're going to cover our limits at infinity, and this is super short. So when the sub shows this one, it should not take more than about 8 minutes max, even if you pause and watch it twice, because all we're going to do is our pre-calc limits. That's it. So in pre-calc, we call them asymptotes. And so we want to make sure that we remember there's 3 options. Okay, so pre-calc, we call those horizontal asymptotes. Okay, so horizontal asymptotes. And so we're going to follow the same 3 rules that we did in pre-calc. So the first rule was, let's pretend that the bottom is bigger. And what we said in pre-calc was, we want to talk about what happens when these numbers get super, super big. And so we said, well, none of these matter except for the largest degree on top and bottom. So then we said, well, this is really like 3x over 4x squared. And then we simplified. And we said, okay, what happens if I let this number right here go super, super big? Okay, and then we said, okay, well, this is going to go to 0. So option 1 was bottom bigger. And if the bottom was bigger, we said we had a horizontal asymptote at y equals 0. Okay, so that's option 1. Okay, option 2 looked like this. And we said, okay, so we said again, we want x to be really, really big. So we're only going to look at this. So this is about the same thing as this. We can ignore that number. So when we talk about infinity, that is not going to matter. And then we said, okay, well, let's reduce. And we got this. And we said, okay, if they are of the same degree, option 2, they're equal, then we said that we just need to look at the ratio of the coefficients connected to the largest degree, top and bottom. And that would be our horizontal asymptote. So we have a horizontal asymptote at y equals 3/4. Option 3 was where the top is bigger. And so, for example, we might have had 4x cubed minus 17x all over 100,000x. Because the number doesn't matter. This is important. The number doesn't matter. So we take the largest degree on the top and the largest degree on the bottom, and let's say approximately, because we're talking about infinity, 100,000. And so now we reduce. And what we really end up with is some number, who cares what it is, times x squared. Well, as we let x go to infinity, this number is going to go to infinity. And so then we said, hey, we have no horizontal asymptote. Okay? So this is what we did in pre-calc. Well, the only difference is we're going to go to calculus and we're going to use limit notation. That is the only difference. So what we want to do is we want to take a look at the largest degree, top and bottom. We want to simplify that. And since this number is going to get extremely big, we say this is going to go to 0. So the limit as x goes to infinity of this function, we say that's going to be 0. Done. So now we come to example 2. And we say, oh, hey, look, these are of the same degree. So we can cross those out. And we can say now that the limit as x approaches infinity of that function is just going to be the ratio of the coefficients. In this case, 3/4. And now we have the last example. So again, largest degree, top and bottom. And we say, okay, let it go to infinity. So we're going to simplify. And we get 3x over 1. And as I let x go to infinity, this number is going to go to infinity. And therefore, we say that the limit as x approaches infinity of that function is infinity. Okay, we don't say no limit, we just say infinity. And we'll talk about the details on that one later. Okay, so they're not all going to look so pretty. So let's do an example where it maybe looks a little funky. So what if I said the square root of 3x minus 2 over 17 minus the square root of x? Okay, so that one looks uglier. And we want the limit as x goes to infinity. So we're going to follow the same exact process. We're going to take our box and look at just that. So we want to simplify this a little bit. And we want to say, well, this is really just the square root of 3x over negative square root of x. And I want to split this up to the square root of 3, the square root of x, over negative square root of x. And those go away. So this is really just negative root 3. This then becomes the limit. So the limit as x approaches infinity of this function is really just negative root 3. I know it looks uglier, but that really is just the coefficient divided by the coefficient of square root of 3 over negative 1. Okay? So that's all you're going to do. You're just going to do that over and over and over again. The most important thing to remember is you're looking at the largest degree. The order in which it's written is irrelevant. Okay? So easy problem set today. You're going to just do the problem set. It's on page 817, and you're going to do numbers 9 through 28. If I were you, I'd look at every other, or I'd look at just the odd ones. If your odd ones are wrong, then go ahead and try an even one just to make sure you can do it. The other two things I want you to make sure you are looking at are your limit packet. I told you we would come back to that when we hit limits at infinity. And so the limit packet, you have two of them. You have the first one where it's the graphing one. And then you have the second one where it's just a bunch of words and it says the limit as x goes to infinity. Okay, so you have the graphing one and then you have the finding limits algebraically. Okay, I'm going to collect both of these tomorrow. These are both due tomorrow. Yes, it's on. Okay, today's problem set should be fairly short. If you do just the odds, you won't have any problems finishing both of those packets as well as the bookwork. Okay. And tomorrow you have a quiz, so Quest on 11.1 through 11.3. All right, so tomorrow's Quest is 11.1 to 11.3. You can come early in the morning, or you can come in during intervention and ask any questions you have, okay? But make sure you come to intervention with questions. All right, good luck.